Welcome to the second module of Variable Valve Timing 101, sponsored by Cloyes. In this next one, we're going to find out what can go wrong with variable valve timing. What happens when the oil's not right, the timing of the engine's not right? Well, we're going to find out from Cody Smith what can happen and what you need to pay attention to diagnose these systems. Welcome back to T2 University, sponsored by Summit Racing. Today's module is on variable valve timing diagnostics. This is module number 2. So today we're talking about diagnostics, maintenance, and inspection on variable valve timing. With this, we're going to understand what can go wrong with these components and what is needed to correct them and diagnose them. So today we're talking a lot about VVT, but the main thing that powers just about every single component on it is engine oil. If a technician is inspecting a vehicle, what do they need to pay attention to on the oil system?
Well, first thing that you need to make sure the engine has oil in it. So, make sure the oil level is where it needs to be. Second, make sure the vehicle has proper oil pressure. Without good pressure, the phasers aren't going to, operate as they should. Oil quality is also a really big factor. Engine contaminants and oil sludge can affect these components just like they do any internal engine component. The solenoids have really small screens to ensure that contaminants don't make it through, but those screens can clog, so you need to make sure the solenoids are free from any kind of buildup. And then consider the mileage of the vehicle as well. You could have good oil pressure, but a lot of these components are fed through, for instance, the camshaft phasers are fed through the camshafts a lot of the time. So camshaft bearing, journals, it's important that they don't have too much wear where you're getting, cross flow. You want to ensure that the oil is making it to the phasers as it should.
I guess another question is the type of oil, the viscosity, the grade, the manufacturer requirements. What does a phaser need depending on the make and model and its design?
Yeah, a lot of that's going to depend on the make and model itself. Definitely follow the OE manufacturer's recommendations on oil weight. And definitely keep the oil changed as they recommend as well.
And as far as using the correct grade, when you're doing one of these jobs, is it always recommended that you change the oil on the vehicle?
Yeah, absolutely. There's no reason if you're doing any kind of maintenance on the internal engine components, I'll always change the oil while you're there.
So, Cody, with this actuator, internally, I can't see what's going on inside, but what fails internally on this phaser that could cause it to malfunction?
Yeah, there's a few things. Phasers are a pretty simple product. You got oil going in one side or the other. It's just moving the rotor inside of the stator. But there are a few fail points. One would be the locking pin. The locking pin works with a spring behind it, and it releases itself with oil pressure. So, contaminants or buildup inside the phaser can prevent the locking pin from either unlocking or from locking back when the oil pressure is gone. So, locking pin function is definitely critical. Vane wear is another issue that can happen. Each chamber between the rotor and stator is divided by a vane of some kind. The designs vary, based on the application. But vanes can wear out. Some of them are nylon, some of them are steel. But if you start losing, contact between the rotor and the stator, you can have cross flow, which will cause, instability inside the phaser, or just a lack of control. The computer is going to send a signal. It's going to be expecting the results, either advance or retard like it should, and cross flow can prevent that from happening. And then, of course, just buildup, like I just mentioned, contaminants and buildup can prevent the rotor from moving smoothly inside the stator.
You said something very interesting, stability inside of it. With the valve train itself, you've got a camshaft, you've got lobes, you've got springs, you've got valves. What happens if there's not enough oil in here?
Well, one, the phaser isn't going to unlock if it's not getting enough oil. And then, if the phaser is unlocked and it's not full of oil like it should, one chamber or the other, you can get a rattle out of the phaser. It can experience instability. where, like you just mentioned, valves, the valve train instabilities can transfer to inside the VVT, causing some internal instability as well.
So understanding what controls the phaser, it's this component right here. You called it a solenoid before. How can this fail on a vehicle?
So there are a few things that can happen to the solenoid. It is an electrical part. It's counting on the pulse width modulation signal from the computer to function and tell it, which ports to supply oil to. So it can experience just an internal electrical failure of some kind. It also has very fine screens where the oil's coming into and out of. So if those screens are clogged with any kind of debris or contaminants, that can affect the function. And then some solenoids have an O-ring that actually seal the bottom of the solenoid into the feature in the head that's installed to. So if the O-ring fails, it can allow too much oil to purge outside.
I guess the question is, now we've gone through the phaser, we've gone through the control valve. Another thing that all these share in common is the timing chain. How does the health of the timing chain dictate the health of the variable valve timing system?
It's really hand in hand. For example, on an application where you have multiple camshaft phasers on the same head, the timing chain is actually setting the initial timing between each camshaft. So chain fatigue, which is a normal happening, it's a normal occurrence in chain engines. Chains fatigue over time. When I say fatigue, that means chains stretch over time. So really the timing between the two camshafts in a single head can be affected by chain stretch.
Okay, here's a scenario. A technician gets a car in for inspection. He notices that there's a code for the variable valve timing system, and he's also hearing a rattle during startup. What should he be looking for? And walk us through the steps of, is it the phaser first? Is it the oil condition first? What should he first be looking through as far as, let's say, a flow chart?
Yep. So, first you're going to do the things that require the least amount of labor, of course. So, ideally you would look at the health of the timing system, but that requires, a timing cover removal in most cases. So first you're going to check oil pressure would be my recommendation. Make sure that the engine still has healthy oil pressure. Of course, oil condition as well. Maintenance records, make sure that the health of the oil has been taken care of. But then, definitely lean on what engine codes the computer is telling you, is going bad. Beyond that, it's going to be more visual inspection, but it's going to require, valve cover removal or front cover removal to really look at the health of the timing chain system. Because rattles, that can be VVT system, but it definitely can be, timing chain system as well. So you want to check tensioner extrusion to make sure that the chain is still at a healthy, healthy in its fatigue life. Check guide wear. Guide wear is going to be a very good indication as to how healthy that oiling system has been. And then, of course, just what the inside of the engine looks like. Make sure, it doesn't have a lot of sludge buildup. But from there, once you get into the engine, you're there, you might as well put a nice, a good timing chain setup in there while you're there and service the VVT components.
And that kind of brings us to our next module, which is coming up next. But first, we have a series of questions and scenarios for you to solve so you can move on to the next module and get your certificate.